Alright, we're back. So I want to get a micrometer for doing the ID and a OD mic. So let's see if this will go down small enough. We're 2050 roughly. So there you go, 2050. Yeah, looks like it'll work. Alright, got down small enough now. Okay, now I can actually measure some stuff and see what we really got for clearances. So we know what we're working with. Alright, so now we're going to go ahead and pull this up. Center up our distance here. Make sure you don't knock anything off when you spin it. Okay, see where error's at. About that much. Whoa, way off that way. That'd be at least 15. Oh yeah, we're gonna be way up there. About pinned it. Okay. I don't like a lot of pressure on my indicator, so I bend it around where it's more equal. Okay. So we were off by 31 and 12 from just eyeballing it. Doesn't seem like much, but actually it is. Okay, so right now our indicator is right there. Okay, just over 5. Just got a high spot right there, look at that. Just over 5, just under 5. And it went over 5 on that side. So we're going to put this thing at 6. Do the same thing. So we moved it 4 6/10. Not a big change. Okay, I'm going to get this back closer to 5 so I can see the error easier. I like being on a hard number. Alright. Looks like we're on 5.5 over there. That's 5. That's 5.5. This is 5.5. This other side's like 6. So the low spot seems to be on that corner way down there. Surprising. Okay, so this one here is 5.5. And this one over here is 5. So you knock it over a couple tenths. Lower what it was. Right there. So I moved it 4. So dial indicators and digital readouts do not agree with each other. This is more accurate. Never believe digital. It's got a scale in the back here that reads some kind of a light beam or something. I don't know what the hell it measures, but never believe digital as being accurate. Mechanical is always better than electronic. Okay, this got a low spot there and a high spot over there. So we're in some kind of a low spot right here. Okay, that's 5.5. And that one over there is 6 or so. Okay, so this one needs to be moved also Why is this one different? This one's at 6 right now. I don't know why it's at 6. That one's at 4, which I don't like. I want to be negative 2 or 3. There's negative 3. And this one here, we're going to move it toward me. Wrong direction. That was 4 the wrong way. We want plus 2 or 3. There's 2. Okay, let's see what we got here now. Looks like we're still up there about 6 thousandths, quite a bit. 5.5. Look at that high spot right there. I think that was a 7 almost. Over here we're at 5. 7 that way. Six over there, 5 there. I'm going to go plus, not plus 6, I'm thinking plus 4. You have to sneak up on it like this. When you go too much, you got to come back. Problem is it moves easy one way and not the other. Always make sure you're in a neutral position because it will change on you. Okay, that's 5.5. And looks like we're about 5 3/4 over there. I'm good with that. That was definitely over 5, but not a lot. Low 5. Back up to 5 high. And we're really high right here. It's our worst spot right there. See, checking on the 45, that's our worst spots. That's our highest spots right there. If these other 3 are even, then I'm going to discount the other one that's off. Just like this, there might be a low spot in here too. I'm in the middle of 2, so you're going to compensate. Okay, basically right now we're at just over 5 that way. If we go over here 180, it should be the same. Yeah, about 2/10 different at most. We're at 5 right there. And we know we're really high on that side. So 5, 5.5. 5.5, 6. I think I need to go. We're at 4. Need to go at least to 5 on the plus side. 1/10 doesn't sound like much, but it makes a difference. 6 is probably too much. I wouldn't mind trying 6, but I don't want to be as. Definitely want 5 for sure. Yeah. Going back and forth. I want to move 5. Yeah, went to 6. And so we went to 6. Look what the dial indicator shows now. We picked up half a thou on doing that. And 5.5, pretty even on that. About the same. This one you go another 1/10 more. We're at -3. I'm gonna do something. -4. I think that's going the wrong direction, but we'll see in a minute. Not sure which way negative's going. See that spot just bad as hell right there. We're really low right here. High over there. So when -4, I need to go back the other way. I need to go to -2. 3, 2. Okay, we're half down at 45. we're half a thou on this 45. I actually dropped this. Yeah, it's half a thou. So these two are equal right now. And this one is at just over 5, but barely 5 1/4. And this one's going to pop its way up. And now we're like, yeah, about 5 3/4. So that's actually not as bad as it was. And that's half, quarter, half, and half. I'll live with that. Okay, so we evened up all our numbers. So we still got our bad spot right here, but everything else is pretty close. Okay, that's in that one spot. Now, go ahead and zero this out. So we move that thing 6. Okay, so now we're going to go down, all the way down the bottom. Figuring that's where the good metal's at. And let's see what we got for numbers now. Looks like it went up a little bit. Quarter of a thou there. We're about half a thou there. We're way up right now over here. And over here, dropping back down. So we have gained a bunch right in that corner. And we're at half right there. We're at half right here and climbing. There's half right here. Get over here, we're at 3/4. These keep going on up. There's 1. Over here, we're half. Flopping around, we're about 5 3/4 over there. So now we're way off on this corner here. And we are down there where the parent material is. Which means there shouldn't be a lot of wear down there, but if the bearing is going all the way in that deep and rocking around a little bit, that can make a little mushroom spot right there. So let's go take another reading. But the bearing, you would assume, would probably slide out because it can't go in when it's loose. But I'm going to go check it further up, see what we get on those dimensions. Okay. About the same as we were before. Half to 0. So the top and the middle is equal. The bottom down there is where our air is at. Now theoretically the bottom is where the no wear is at, but is that actually true or not? So that's a judgment call. Do you want to go for it or you want to not go for it? Over half. We're at 1 right there. We're over half, 3/4 there. Low half there. And high as hell over here. So I'm going to go ahead and average all these numbers out. So I'm going to move it. We should go -2/10. Just have to go this direction. Back to that 2/10 number we had before. Okay, so now we're a little bit higher on this side. And we're still a little bit higher than that over here, but not by much. We're 6.5 there at least. And we're 5 3/4 here. Heavy there. And heavy there. So I think that's a good call, doing a 2/10. That makes all 3 levels up to the that we're measuring at kind of more equal overall. So we went back that 2/10 we took back out. So there we go. Alright, so I'm happy with that. I'm not seeing a hole that's going sideways like this where your numbers would be really staggering. We got the same, and then one corner is way over. And and we average out that corner, so we should be good. So my guess is there's a little pressure on this side right in here, or there's a high spot on the bottom, one or the other. Okay, so that's how you do that. Now we got to figure out what the hell we're going to do from here. So first thing I do is measure your hole size and see what kind of clearance we got in here. And we're using a mic, which is way more accurate than anything else you can ever use. Dial bore gauges have an average of 3. Snap gauges measure 2, but they're slip fit, so they can be an error. A mic is mechanically adjusted to a hard number, so it's the most accurate. But you can still have an error too if you're not careful. You do have to center it in the hole. We definitely have some taper in there. Okay, what do we got? We're at just under 0. That's 2/10. And we're 1/10 over, so we got 3/10 taper for sure in the hole on that direction. Like dial bore gauges make it easy to measure taper if you can see it easier. High up there, you can hear it popping over center. And this one's about 1/10 under. Okay, so the out around us isn't too bad. The taper is definitely in there because the bearing worked it out, it was wearing the cover more. And it was probably spinning, which caused more problems. Okay, so now I'm going to go ahead down here and measure our bearing. The X are pretty close to each other, which is nice. We are about 1/3 of a thou. And the mic, oh no, we're way off. The mic is showing 1/4 over and we're 1/3 under, so it's 8/10 error. This mic moved because it wasn't that tight. Yeah, definitely not that tight. Okay, that is just over, oh, it's a little bit big right there. Okay, it's for 1/2 a thou. Where's that 1/2 at? Low, wasn't it? Okay, we're 1/3 of a thou to 1/2 a thou low, depending on how much pressure you're putting on it. This is loose. And this is 2 1/4 thou lower. So we're running 2 thou clearance on this bearing to the primary, to the cover right now. That's why it's loose. 2 thou. Now theoretically, Loctite's supposed to seal that up and not be a problem, but it don't work. The Loctite's not holding. It's knocking it free. So the spinning load on the Loctite and the transmission pulse and all that, once the Loctite starts to move, it comes loose. Loctite works really good as long as it doesn't move. Once it starts to move, it's not going to hold up. So you got to make it tight. So we need 2 thou plus a press fit of probably 1 to 2, depending on how much press you want to put on it. You know, so something this big, 2 thou press would be pretty good. 1.5 thou might be a little better, but definitely 2 thou would be a good tight prit. And so that means we gotta have like 4 thou smaller hole than we got now to make it what we want. So that's what we need to do with this. So I need to make this thing now and bore that out to fit that. I'll leave this a little bit small on the ID because I'll have to on the finish board in the machine. We're going to press the sleeve in there with Loctite on it, and then we'll come back and bore the hole again. We'll come back and center up the hole and get an idea where we're at, and then we'll come back and finish bore the hole, and hopefully we come up with the number we want. Somewhere between 1 and 2 thou is our tolerance press fit. 1.5 thou is more the sweet spot. So if the machine, if the first surface is a little bit rough, then you want a 2 thou because you push it in, it's going to smooth it up a little bit. So there you go. That's what we need to do. So I need to make a bunch of parts. So the first thing I do is make the important part, the sleeve. So right now, this end does not work because it's bigger than the bearing. Or the bearing's bigger than the surface we need, so that's not going to fly. So that means we're going to be using this surface over here, which is way fat. So the ID is way small and the OD is way big, so we got to turn this thing down. And we need to make it a certain depth. And the depth right now appears to be probably about 600 on the inside of the chamfer, but we don't want it to be on the inside of the chamfer. We want to make it more straight, so it'll come a little higher. I don't think I get it on my caliper. Get an actual real number. Nope, I can do it. Good. So if we come all the way to top surface, 590. This side over here. That angle, get that out of the way. .617, so 600 thou would be plenty. The steel will be a little bit above the chamfer, but that's okay. So we're looking at 600 thou cutoff, the bushing height. 50 wall is what we're shooting for. So that means we're going to make an OD that is 50 thou bigger than this. No, it's 100 thou more than this because it's 50 wall. So it's 2046 right now. 2046 and a half. So we're going to make that 2.146 or 147, something like that. Now, being a thin wall sleeve, you're going to have a decent amount of press into that, but with a press on a press, 2 thou should carry over. Give yourself 2 thou on a sleeve. You push the other one, you get another 2. That should push it back up to the same number. But that's why we're going to bore the hole after it's done, not before. When you do the final bushing, everything's done at once, and you have to guess what everything's going to move around to. I've done that. It's tight, but you have to guess how much it's going to contract this way, and then push the bearing on that. How much it's going to sludge back up that way. And it becomes very, very tricky because 1 thou can kill you. You pinch a bearing too much and it won't work. It starts locking up. I've done that on my race bike. It's hard. All right, that's it for now.